Hi, Emil. Thank you for inviting us to your booth. Can you tell us a little bit about Adaxis?
Yeah, so I'm Emil. I'm the Chief Product Officer of Adaxis, and we are a software company for robotics, and specifically how to use robotics for additive manufacturing.
Okay, so you're focusing on mainly pellet extrusion systems and also CNC?
So polymer extrusion is a very big part of what we do, but we also work a lot with metal additive, so wire arc, wire laser, a lot of the metal additive processes you can put on a robot.
Okay, so it's like a full software package for
Yes.
for large-scale 3D printing.
Yeah, anything, configuration of the whole robotic cell, and then programming of the robot cell, and then finally monitoring to make sure that what you're printing is actually what you want to print.
Okay, and is this a little bit like a desktop slicer? That's what I'm more familiar with from coming from filaments.
Yeah.
So you can just select your printer and select your material and...
A little bit like that, yes, because if we look at the way that people have typically programmed robotic arms in the past, it's been the same for more than 30 years pretty much. And it's been typically very complicated. So our initial approach was to go more towards the way we work with a regular desktop printer, because that is very convenient, it's very common for people, they understand it. And then of course now we have added a lot of really advanced things that will allow you to do really amazing things with the robot, printing multi-axis and so on.
Oh, great, yeah.
But it's all really based on the fact that it should be super intuitive.
Okay. Yeah, well, let's dive into the software and have a closer look.
Yeah.
So here you have, so you have the print. This is a track printer.
Yeah. So this is actually a seed FlexBot. So it's a linear track, and then we have a Comau robot with a pellet extruder at the end of it. And when we have a robotic cell like this, we spend some time just to set it up to make sure that it exactly represents reality and the robot cell that you have in your workshop. We configure the materials and extrusion head, and then finally you drag in your part. So it's just a 3D geometry, a step file or a mesh of the part. And we can take that and immediately, with just a few clicks, create the toolpaths. And when we have a toolpath, we need to know how the robot is going to behave, because the robot can be a little bit unpredictable. So here we have the robot simulation. And the one thing that we really pride ourselves on is that everything is super real time and you get visual feedback. So here, for example, I can move my part while the simulation is running. Maybe I want to see what it will look like when I put it somewhere else. And I can just start and drag it. When I release, the simulation is immediately updated. This allows you to work super fast with the robot, even though it is very complicated.
Okay, and so how does Polymaker and Polycore tie into this system?
So the final piece of the puzzle is that you need to understand how to print the material you want to print. And large scale is nothing like small desktop printers. So the material plays an insanely important role. I mean, if you don't have if you don't manage the distortion, the part's gonna come off of the build platform. If you don't manage the layer time, the layers aren't gonna stick. So we have built a material library where, in collaboration with you guys, we are integrating the materials so the users just have to apply the settings with a single click as well. And that's the final piece of the puzzle to get really beautiful
that usability that people are familiar with
exactly.
Desktop slicing. Yeah, great.
Exactly.
Cool. So I see it looks like you're doing a non-planar piece now. Is that like a setting that you can do?
Yeah, so we have developed, I think, it's more than 10 different slicing strategies for different kind of geometries. So it's anything from, regular, good old-fashioned horizontal slicing to radial, multi-planar, where we're following a guide curve. So this is what the part would print like. So it's really following the shape of the part. But we also have other very creative ways to print parts, where we interpolate between surfaces and so on.
Cool. So is it possible to use two slicing methods within one print?
Yeah. So that's In that case, we're creating 2 different toolpaths, and then we have actually just now released a new feature. That is a toolpath sequencer, which allows you to stitch together multiple toolpaths seamlessly. It's almost like a video editor. And then you can just decide if they're going to print in parallel or in series, and it's super neat, actually.
Very cool. Okay, well, I think that sums up really nicely, Emil, what the Adaxis is doing. It seems like a really nice piece of software that you've developed here. So thank you for having us on the booth.
Yeah, thank you for a great collaboration. Look forward to working here even closer in the future.